Picture this. You stay up late wiring 12 shiny model context protocol servers into your favorite AI assistant. Git, search, calendars, vector stores, internal API bridges, the whole buffet. You hit run, expecting a supercharged copilot. Instead, your once snappy assistant now hesitates, stalls, and starts missing embarrassingly obvious cues, like it suddenly forgot how to do its job. Here is the twist. You did not just make your AI smarter, you quietly overloaded its brain. If that sounds familiar, you are not alone. Browse a directory like MCP.so, and it almost dares you to install one more integration. Hundreds of servers promise more power, more reach, more capability, and our instincts cheer that on the same way 20 browser tabs feels like productivity. But as Robin Ebers bluntly puts it in the talk, more MCP servers does not equal smarter AI, that instinct is flat out wrong. In a minute, I will show you why adding tools can literally make your model dumber. Here is the real villain, context overload. Every MCP server you add does not just sit there quietly. It injects prompts, schemas, tool descriptions, and usage examples into the model's context window on every single call. Modern agents already juggle user messages, system prompts, code, and logs inside a finite working memory. Now imagine burning thousands of tokens just to describe your tools before the model even sees the actual problem. The pattern break is this. Your AI is not slow because it is weak. It is slow because you buried the task under a pile of manuals. Think of an MCP-enabled model like a developer standing in front of a workbench. With three clearly labeled power tools, they grab what they need and move fast. Now swap that for 50 overlapping gadgets, all with similar labels and slightly different switches. Every action starts with hesitation, second guessing, and context switching. That is exactly what your agent does when you wire in 10 or 20 servers that all kind of do search, code, or shell commands. The more branches you add to its decision tree, the more ways it can go wrong. Here is the counterintuitive thesis for 2025. Fewer, sharper tools win. The reflex to install just one more server mirrors the old microservices bloat that crippled web apps with latency and complexity. We are repeating that exact pattern in AI, and the bill shows up as slower responses, higher token costs, and more hallucinations. This is not just a neat optimization trick. It changes who gets reliable AI in production and who ships something that looks great in a demo, then falls apart under real load. To understand why, you need to know what MCP actually promised. The Model Context Protocol was designed as the USB-C of AI tooling. One simple, JSON-based contract so any model, agent, or IDE can discover tools, authenticate, and call them in a standard way. Build a server once, and it can plug into Cursor, Claude Desktop, or your custom agent without bespoke adapters. That interoperability is real, and it unlocked a whole ecosystem. But here is the part nobody says out loud. MCP never claimed that more servers equals more intelligence. The protocol standardizes the plug, not the number of things you should plug in at once. Its job is to make connecting tools trivial, not to orchestrate 50 simultaneous integrations in a single prompt. When you treat MCP.so like a grocery store and fill your cart with every server, you are misusing the standard. The result is an agent that spends more effort reading its own tool catalog than solving your problem. In a moment, we will break down the three concrete ways this shows up as measurable performance decay. First, let us talk about how your AI's brain actually works. Human psychology tells us our working memory holds maybe 4 to 7 chunks of information before errors spike. Give someone 50 tools and a laminated sheet for each, and they will start grabbing the wrong thing after number 20. Models are not magic here. They have a context window, not a soul. 8,000, 32,000, maybe 200,000 tokens of short-term memory. Stuff that window with tool manifests, and you push your real task off the edge. Every MCP server you add is another set of capabilities, arguments, examples, and safety rules jammed into that window. On each request, the model must parse all of it, infer which tools might apply, compare overlapping abilities, and then remember how to call the chosen one correctly. That is cognitive load just in silicon. The more servers you bolt on, the more time the model spends thinking about its tools instead of your question. If you have ever seen an agent flip between multiple search tools or ignore the perfect code indexer, you have watched that overload in action. This leads to what you can think of as the three horsemen of performance decay. The first is the token apocalypse. 10 to 12 servers can easily consume 1 to 2,000 tokens per request, just describing themselves. You pay for those tokens twice, once in API cost and again in lost space for code, logs, and conversation history. A 200,000 token model sounds huge, but if half of that is boilerplate tool metadata, your agent is working with a blurry, low-fidelity view of your actual problem. The second horseman is latency lag. Tool using models do not just read the prompt. They run an internal search over it, simulating different plans. With each extra server, they must scan more descriptions, weigh more possible action chains, and explore more what-if branches. A setup with 3 or 4 tightly scoped servers might respond in 2 to 4 seconds. A 12-server zoo can easily drift into 8 to 15 seconds, especially when tools chain. That delay is not just annoying. It changes whether your team will actually rely on the assistant in their daily work. The third and most dangerous horseman is accuracy collapse. When you have multiple servers that all expose search, run command, or HTTP endpoints, the model must guess which one you meant based only on their natural language descriptions. It will often pick the slower or less relevant option or avoid tools entirely when it is unsure. You see it use a generic search instead of the project-specific code index or hit a remote file system instead of a local one. On paper, you added capability. In practice, you reduced clarity. So what do you do instead of hoarding integrations? The answer is to move from collector to curator. Treat your model's context window like precious RAM on an old laptop, not an infinite warehouse. Start with 3 to 5 real workflows, like triaging GitHub issues, summarizing customer tickets, or generating release notes from commits. Then map which MCP servers those flows actually need, step by step, under real prompts. In a moment, we will walk through what a simple 3-step MCP audit can look like. Step 1 in that audit is brutal pruning. List every MCP server currently wired into your agent and mark how often it is actually used in logs over a real week of traffic. Anything that is rarely or never called should be a candidate for removal. Step 2 is to eliminate redundancy. If you have 3 different vector search backends or multiple HTTP clients, pick one and delete the rest. Step 3 is to tighten descriptions so each remaining server has a clear, non-overlapping role the model can easily distinguish. When you do this, something interesting happens. Your AI feels smarter without you changing the model at all. Responses get faster because there is less to scan. Accuracy improves because there are fewer near-identical tools to confuse. And costs drop because you are not wasting thousands of tokens on tool metadata. The stakes are real here. Teams that learn to curate their MCP stack will ship agents that feel like focused colleagues while everyone else drowns in their own plugin marketplace. So as you look at your 2025 AI stack, remember this rule of thumb. Less is the new more. You are not building an app store inside your agent. You are designing a small, coherent working memory your model can actually use. If you want more deep dives on practical AI tooling, MCP patterns, and real-world audits, hit subscribe, drop a comment with how many servers you are running today, and tell me if you have felt that slowdown. Because the next wave of AI advantage will not come from